In this video, I'm going to talk about frequency polygons. So frequency polygons are similar to line graphs. In fact, some people, when they're referring to frequency polygons, call them line graphs. There's really no distinction between the two of them, but this textbook makes a distinction in the sense that he likes to use the frequency polygons for continuous data. So we will go ahead and explore using this type of graph for continuous data. And then it also gets used for another type of special graph, which we'll talk about in a second. So when you're doing a frequency polygon and you're working with continuous data, that means data that has decimals. That means we're usually talking about intervals like this example below. And therefore, we're going to have to, in order to plot a point, find a midpoint for each interval. So the formula for finding the midpoint is the sum of the upper and lower bounds divided by 2. Now, as this is, most people would just do 50 plus 60 divided by 2 and get 55. That is completely reasonable. However, our book does make a distinction. Because they don't count 60 as being part of the first interval, he actually goes ahead and calls it 59. In his calculation, he uses 50 plus 59 and divides it by 2, which actually comes out to 54.5. But the truth is, you could round 54.5 to 55, and there'd be nothing wrong with that. So we're going to go with the 55 just because it's a nice clean number. I think it makes a lot of sense for this example, but I wanted to point that out in case you're reading the textbook and you find that at all confusing. So the next one is going to be 65. And then 75, and then 85, and then 95. And by the way, the midpoints increase by 10, which also happens to be the class width. So because each of these increase by 10, so does the midpoint. So if I'm given the first midpoint for the first class, I could find the rest of the midpoints by just adding the class width. Okay, so I'm going to go ahead and draw this very similarly to how I drew line graphs in the last section. So here, I'm going to give myself a little space. All right. So we're going to go 55, 65, 75, 85, 95. Now, I'm going to do something very annoying. I'm going to actually give myself a little bit above and below those two starting points. So I'm going to go down to 45 and up to 105. I'll explain why in just a second. Okay, so the frequencies are, let's see, maybe go by fives. That wouldn't be unreasonable since our largest one is 40. So it'd only make me have to draw 8 tick marks. All right. And as always, I'm going to label everything. Oops. I'll make sure to label my axes as well. Okay, so this will be the frequency. And even though each of these on the x-axis are technically a midpoint, it is representing a test score. And it's a final. So frequency distribution for final test scores. So. All right, there we go. We'll make that distinction. Okay, so let's go ahead and plot each point. So 55 and 5, 65 and 10, 75 and 30, 85 and 40, and 95 and 15. And just like line graphs, we're going to connect each of these with a straight line. So it's kind of jagged. It's kind of a sad line. I don't know if that was much better. All right, there we go. Now, here's why I added the extra midpoints. This is often done with frequency polygons. They actually start off at 0. They connect the graph basically to the x-axis. Now I put a note down here about that. Excuse me. And I said in my note, I don't know why. I'm not certain why they do that. I believe it's because they're trying to look at this as what's called the shape of this distribution to kind of figure out its basic points of where it's basically centered, like kind of where the most data is, where the least data is. And it's supposed to connect to a concept we'll talk about later. I think that might be why, but I'll be honest, I'm not definite as to why they really do that. Now, sometimes they use frequency polygons and do 2 on 1 just to kind of do comparison. So this one is actually looking at the data from the previous example, but it's comparing their final exam grade to their final grade. And you could kind of see, so we graphed ours went up to 40 on 85. And I wanted to point out he used the other midpoints that we talked about based on the fact that he didn't go to 60, he went to 59 and so forth, okay? So the dark blue line is just like the one we did, and the lighter blue line is the final grade in the class. And you could see they're very closely mapped together. So you can kind of get an idea that their score on the final kind of connects to the final score they're going to get in the class. Now, there is one special type of frequency polygon called a time series graph. This is when we use time as the x-axis. So like in this example down here, the annual consumer price index, which is looking at cost being spent by the consumer annually, we notice that it is trending upwards. And that's what this gives us, is an opportunity to look for trends. But a time series plot is just a frequency polygon. You'll even notice in this particular example, they don't even have the dots showing. It's kind of this smooth graph, but you could kind of see that like right here at 2008, it kind of changes direction a little bit to 2009. It actually went down a little bit right about there and then climbed back up again. And it just gives you an idea of what is going on over a period of time, which is a very valuable thing to know when you are looking at data.